All right, class, hello and welcome to the Chapter 13 Equation Review. You have made it all the way to the end. Congratulations. Now let's begin. All right, first section. We are going to be talking about radicals. So the questions we'll ask you, between what two whole numbers is each radical? Between what two whole numbers is each radical? And they're going to give you things like the radical of 6 for number 1, and then the radical of 85 for number 2. And then number 3 is going to ask you the radical of 38. What really helps for me is to break down what the question's really asking. And to me, what it says is, between what two whole numbers? Okay, what's a whole number? Well, that's any number like 0, 1, 2, 3, full wholes, right? Complete things. Is each radical. So between which two numbers, basically, so between which two numbers is each radical? We remember radicals aren't really whole numbers, right? So what the question is really asking is, between what two whole numbers is each radical's answer? So what I mean by that is, this is rad 4, right? The whole number answer to that is 2. So it's really asking us in this question, between what two answers would this answer be in? So let me give you an example. Rad 6, we remember, if we were looking at all the perfect squares around it, we would have, let's see, I know 1 times 1 gives me rad 1, 2 times 2 gives me rad 4, 3 times 3 gives me rad 9. Okay, so there we go. Rad 6's answer, the answer for rad 6 would be between rad 4 and rad 9. The answer to rad 6 would be between whatever the answer to rad 4 is and whatever the answer to rad 9 is. And what those are 2. The radical of 4 is 2, and the radical of 2 is, of 9 rather, is 3. So you can see how logistically the radical of 6 has to be somewhere between those two numbers. So what two numbers multiplied equal rad 6 or equal 6? It's probably what? 2.4 times something? I don't know what it is off the top of my head, but what we're saying is, between which two answers would this radical's answer be? So again, between which two, if we found the answer to rad 5, where would that answer reside between? Perfect squares that lead up to 85. Let's see, I know 6 times 6 gives us 36, 7 times 7 equals 49, 8 times 8 equals, what, 64? 9 times 9 equals 81. So I'm looking somewhere between 64 and 81, which is rad 8 and rad 9. So on this side would be rad 8. Oh, no, not rad 9, 8. That's too low. I'm sorry. 81, you might have been thinking, what is he doing? It's between 81 and 100. The radical of 81 would give us 9. The radical of 100 would give us 10. So therefore, it's between rad 81 and rad 100. The answer to both of those is, or are, I guess, I don't know how that would go. The radical of 81 is 9, right? 9 times 9 is 81. The radical of 100 is 10. 10 times 10 is 100. So the answer to what rad 85 is, let's actually find out what that is so that I can give you a nice clean answer. The radical of 85 is 9.219. 9.219. So the radical of 85 is 9.219, right? So look, do you see how the answer to rad 85 would fall between the answer to rad 81, I don't know what it was, and the answer to rad 10? So let's see if you can figure out the last one on your own. Between what two whole number answers is the radical of 38? I'll give you 10 seconds. All right, that is time. Let's see what we got. So rad 38, the perfect radicals that are around it are 49, 7 times 7, and, well, I guess it would be 6, right? Yeah, there you go. 6 times, or not rad 6, sorry. Rad 36, which answer is 6 times 6. So the answer to rad of 38 has to be somewhere between the numbers 6 and the number 7. And that would be, let's see, the radical of 38 is 6.16. So the answer to rad 38 is 6.16, and that is in fact between the numbers 6 and 7. All right, there's section 1. Section 2, we are simplifying some radicals. So if we had rad 20 for number 4, how do I simplify that? Well, I simply try to figure out what are the perfect squares that go into 20. Well, 1 times 20, here are the factors. 1 times 20, no perfect square there. 2 times 10, no perfect square. 3 times, nothing. 4 times 5, there is a perfect square. What is the perfect square? It's rad 4, because rad 4 comes out perfectly to 2 times 2. So what I can do is I can say, all right, there is a 4 times 5 in here. Then I can reduce it to rad 4 times rad 5, almost like using the distributive property to give the radical to the 4 and to the 5, right? What happens to one is happening to both, so I can split them up. The radical of 4, like we said, is 2. 2 times 2 is 4. That only leaves the rad 5, so my answer is going to be 2 rad 5. I can go no further. Good. Moving on, let's see if you can do number 5. If I gave you rad 27, let's see what you can do with that. 10 seconds. All right, rad 27. I asked myself, are there any perfect squares inside 27? 1 times 27, 3 times 9, right? And 9 is a perfect square because you can do 3 times 3. So if my answer that's going in here are 3 times 9, I can now break it up using what I assume is the distributive property to go rad 3 times rad 9. I just put them right next to each other. I then simplify my rad 9 to 3 because that's the answer to what is the square root of 9, 3. And so I put my 3 in the front of my other 3 because there is no perfect square of 3 to make it the square root of 3. So my final answer will be 3 times rad 3. And there we go. Let's now try some different types of simplifying. Let's say I had a subtraction problem like number 6, and I had 5 rad 7 minus 4 rad 2 plus 3 rad 7. Let's see if you remember how to do adding and subtracting of radicals. I'll give you 10 seconds. All right, let's see what you did. Some of you may have noticed that I use color coding in this one for a reason. Just like adding and subtracting variables, I can only add and subtract radicals if they have the exact same ending radical. So this is a 5 times 7, right? 5 rad 7. I cannot add or subtract it to 4 times rad 2 because the endings are not exactly the same, or the radicals aren't exactly the same. But what I can do is I can combine it with whatever's going on over here because their endings, 3 times rad 7, are exactly the same. So if I consolidate nicely, I would get 5 times rad 7, and I'm taking the positive with the rad 7. Because if it has a negative in front of it, it would become negative 3 rad 7. So I'm bringing that down. So I'm getting the plus 3 times rad 7. Now I'm going to do some simple math. Remember, I can only add the outsides together. That's why they're in the same color. 5 plus 3 is 8. And the 7s stay where they are, just as if they were variables. That's 8 rad 7s. If you wrote that out just for quick divergence, it would be rad 7 plus rad 7 plus rad 7 plus rad 7, that's 4, plus rad 7, that's 5, plus rad 7, that's 8, plus rad 7, that's 9, sorry, 8 of them, right? Imagine each of them had a 1 in front because it's 1 times. How many are there? Well, there's 1, 2, 3, 4, 5, 6, 7. Oh, that's an 8. That's an 8 in there. Sorry. There are 8 rad 7s. 7 times 8. 7, 8. Rad 7, 8 times. All right, but that's not why we're here. So now I have my 8 rad 7. So that took care of that, and that, and that, and that. And then you just simply subtract your 4 rad 2. But I can't subtract 4 from the 8 because their radicals are not exactly the same. So I've got 8 rad 7 minus 4 rad 2 is my final answer. Hopefully you got that one right. All right, let's try some multiplication. As in number 7. Remember, in contrast to addition and subtraction, you can do whatever you want with multiplying radicals. So if I had a 4 rad 2 and I multiplied it by a 9 rad 5, oh, that was terrible. 9 rad 5. I can simply use distributive properties to multiply the fronts first. So 4 times 9, okay. 9 times 4 is what, 36? So that takes care of that and that. And then I can multiply the backs by themselves. So I can do rad 2 times rad 5. And I could combine them if it's multiplication. So 36, and they'd all go underneath 1. So 2 times 5. And we'd say 36 times 2 times 5 is what? 10. Okay. And then I say, okay, can I do anything else? Is there any perfect squares in 10? There's a 1 times 5, or 1 times 10, and a 2 times 5. No perfect squares. This is where my answer ends. 36 times rad 10. All right, now let's try division. Number 8. In number 8, it says 3 times rad 20 divided by a simple 2. All right, how do I do this? Let's see. I'm going to give you 10 seconds to see if you can solve this problem. All right, let's see. So first I say, can I do anything with my whole numbers on the outside? Well, no, I can't, right? 3 divided by 2 doesn't go anywhere. So I'm out of luck there. Then I move on to my radical. Can I reduce that in any way? Well, if I remember from my original lessons, rad 20 can be rewritten as the product of a perfect square, which would be 4 times 5. 4 times 5 translates into rad 4 times rad 5, or the answers to both. The answer to rad 4 is 2. The answer to rad 5 is, well, just 5. Rad 5. So now what I have, in essence, is the original 3 over the original 2, and the rad 20 has been changed into 2 times rad 5, right? So now what I can do is simply use the distributive property to multiply the 3 times the 2. And that will give me, I'm not really using the distributive property. Let me not misspeak on that one. Basically, I said that to make it more understandable for you, but you're not actually using the distributive property. What you're simply doing is multiplying the front numbers, 3 times the 2. That will give you a 6 times rad 5. Nothing happened on the bottom, so it's divided by 2. And now I check again. Now can I divide these two? And the answer is yes. Yes, I can. Because 2 divided by 2 is 1. It's a common factor. And 6 divided by 2 is 3. So my final answer, if I clean everything up, will be 3 times rad 5 over 1. But since anything divided by 1 is itself, we can simply write this answer as 3 divided by 5. Or, excuse me, 3 times rad 5. 3 times rad 5. And the radical symbol does look a little like the division symbol, doesn't it? I must do better to write my, there you go, to write my radical symbols. That's a good point. On your test, make sure that you write your radical symbols clearly, okay? Moving on. Let's try to substitute some numbers. So if I'm substituting a number 13, 2 times rad x, does that equal 8? If, that's what, oh, nope, they're not going to give us an if. So how do I solve this? 10 seconds, go. What is the x value? 10, 9. All right, let's see what we did. So I know I need to try to isolate this x variable to see what it is, right? So if it's me, I'm like a butcher. I'm trying to cut away all the fat. And the fat I see is out here, this 2 times in the outside. Because it's multiplied, I can do the inverse and remove it with a division of 2. So 2 times rad x divided by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. What I do to one side, I must also do to the other. 8 divided by 2 is 4. 2 divided by 2 is 1. This leaves me with 1 times x over 1. But because 1 times anything is itself, this becomes rad x. And because anything divided by 1 is itself again, the final answer for this part, top part, is radical of x. And the radical of x is still going to be equal to this section over here, which is 4 over 1 is what we were left with. I can clean that up to rad x equals 4 divided by 1 is 4. Well, now I need to get rid of the radical symbol, and I know I can do that by squaring it. They're opposites of each other. They're inverses, squaring and radicals. What I do to one side, I must do to the other. So I end up with 4 squared, which is 4 times 4, and that is 16. And these two canceled each other out, so that leaves me with x equals 16. Now all I need to do is prove it. So my original question was, I'm gonna have to erase everything for space. My original question was 2 times the radical of x is equal to 8. Now I say that my x is 16. So let's see if I plug it in, what will happen. 2 times the radical of plugging in the 16 is equal to 8. Well, 2 times rad 16 is 4. Oh, I think it is. 2 times 4 is 8. 8 is equal to 8. X, therefore, is good at 16. Nice. So all you need to do is plug in for those. All right. The final section I will do in another video, and we will be doing the special triangles and the Pythagorean triplets. But for right now, I'll leave you with this final problem. Four times n plus 2 is equal to 20. Find out what n is equal to. Try to solve the problem before I do. All right, hopefully you got x equals 23. There is the proof and the pudding all together. Hopefully you got that right. If not, try to figure out what went wrong and how you can fix it. And we'll see you in the final part, 3, for the chapter 13 review.